Development is important across all organisms. We know for a fact that development is tightly coordinated by hormones. Humans, for instance, go through 3 distinct life stages: the juvenile phase, when they're a child, the pubertal phase, when you're a teenager, and then the adult phase. The organism that I look at, the tobacco hornworm Manduca sexta, has similar developmental processes at work. There's similar developmental stages. In the beginning, they're eggs forming into larvae. They go through a pubertal phase in a pupa, where hormones are flushing around, and then turn into an adult moth. It's been noted in children with diseases such as cystic fibrosis that the onset of puberty happens much later than healthy individuals. That's caused by tissue damage from chronic inflammation of the lungs. In Manduca sexta, when you damage cells on the side of the organism's body, it causes delays to pupation and to adult moth eclosion. For my first question, I wanted to see if there's a time point during the last larval instar where you cause tissue damage and delays are no longer existent. I found that after a certain day during the last larval instar, that delays cease to exist. Secondly, I wanted to see if this delay pattern would happen from earlier instars, meaning earlier life stages, if that would be delayed, or if it's just delayed from pupation to eclosion. I found that there is no delay from 3rd to 4th, or 4th to 5th larval instar, but only delays from the 5th larval instar to pupation, and from pupation to eclosion. That again led me to believe that these hormones are at play. So my final experiment that I wish to do would be to get hormone levels during the last larval instar and compare them to the days where I see delays, and to coordinate that and further narrow down which hormones are at play. But this brings to matter, why do these delays even exist? The delays are there to be had for tissue repair and regeneration in order to ensure that the adult organism lives a more healthy and prosperous life.